Hello, everyone. So the goals of this short talk today, I want to give an overview of some of the ways to deploy MPLS over IP in general, as well as MPLS over IP within a context of specific MPLS applications, specifically RFC 2547 VPNs. I'm going to focus down in on that just a bit. And in the process, we'll talk about some of the security issues of MPLS over IP and evaluate pros and cons of several different IP tunnel types that could be used with MPLS. So we start out with the most generic case. This is MPLS over IP with a manual point-to-point tunnel configured, potentially a GRE tunnel, probably a GRE tunnel. We can use other encapsulations though. The tunnel in this case acts as a link layer between two MPLS networks. We have top an MPLS network, down bottom an MPLS network. They happen to be connected via this IP network, but we configure between two P routers a GRE tunnel. This connects the disparate MPLS networks over IP. So what this looks like is the GRE tunnel then just looks like a regular link. So the two separate MPLS networks, in fact, become very much like one big MPLS network. Hence, the LSPs are set up between all the nodes as if it was one large MPLS network. There's no hierarchy being imposed here. So since this is one big MPLS network, of course, you can run MPLS services such as 2547 or Atom or what have you across both clouds. So you can expand this even more to multiple MPLS networks. You can even pick out a particular PE. The violet colored PEs in this diagram are only reachable via the IP network. However, we've set up GRE tunnels, point-to-point GRE tunnels to those PEs, which we run MPLS over, run MPLS code on the PE, and then I, again, extend this MPLS network, make it even larger and larger. So after you do this, all these manual configured tunnels can actually become cumbersome. The nice part is that it's generic MPLS everywhere, so you can run 2547 or what have you. The maybe not so nice part is that it's making your MPLS network very, very large. One GRE tunnel can double the size of your MPLS network. So let's talk a little bit about what we can do if we're targeting a specific MPLS application. And in this case, in RFC 2547 VPN support. So if we target a specific application, we have a few more options. Instead of manually configuring tunnels, we can use the tunnel reachability information sent in a BGP Next top tunnel SAFI. And I've included a reference to an internet draft that proposes how to do this. This tunnel SAFI advertises which tunnel method is best to reach a given PE. And since RFC 2547 operates just between the PEs and doesn't really interact with the P routers, all I really need to do is advertise how to get packets from one PE to another, whether that be via an MPLS LSP or MPLS over GRE, MPLS over L2TP v3, and we'll talk about more options later. So this includes any necessary point to multi-point type parameters, anything that's common to a given PE that every other PE has to know about, such as the protocol type that you can receive the MPLS packet on, any kind of IPsec policies, the security associations, an L2TP v3 session and cookie, etc., depending on what flavor you're using to reach that particular PE. But what's important here is no additional configuration is necessary at a PE beyond locally enabling that encapsulation mode. If you go around each PE and just enable what that PE can do, then the PEs that can do the same thing will naturally talk to one another that way. IPsec is a bit of an exception as it requires IKE for the security association setup. So you can't get around that point-to-point full mesh of PEs talking to one another, at least currently you cannot. And so you still have that centralized either shared key or public private key or what have you to set up your security association, your policies and associated stuff. So what does this look like? And this is the same diagram as before, but instead of configuring that manual GRE tunnel, the PEs which can talk via MPLS do so. And MPLS over LSP on this chart, I mean MPLS over label switch path. So MPLS over label switch path is used when possible, MPLS over IP when not possible. So this can be quite useful in MPLS migration scenarios because what I haven't done here is taken the two separate MPLS networks and made them one big MPLS network. All I'm doing is saying, if the PEs have to talk IP, they do. If the PEs can talk MPLS, they will. This is also useful if there is no MPLS in your core. If you only have MPLS, if you want to deploy an MPLS 2547 VPN service, you can enable MPLS only on your PEs, and your core remains IP only. MPLS runs at the edge where it needs to for 2547. And this allows you to deploy 2547 service without moving to MPLS right away. You can still have plans to move to MPLS, and that's perfectly fine, but it allows that to evolve on its own course independent of the 2547 deployment. So what are some of the cons of MPLS over IP versus MPLS over an LSP? Well, the MTU is decreased. IP header is bigger than a label. At least 16 bytes, that's the MPLS over IP case. Also, it's reported in a number of internet drafts, in a book or two, what have you, that an IP core may be more vulnerable to spoofing attacks versus an MPLS core. I believe actually that was even mentioned in a talk at NANOG a couple of years ago. So this could be an issue, and we'll talk about that. Also, there's potential interoperability issues that can't be ignored due to the multiple encapsulation options. So here are some of the options that are currently defined in various IETF drafts. One is MPLS directly over IP, keep it simple. MPLS over GRE, MPLS over LTTP-v3, any of the above with MPLS over IPsec transport mode. So whenever you see MPLS over IPsec, it's not IPsec tunneling like you do from your laptop or between firewalls. There's no IPsec tunnel mode. To IPsec, it looks like transport mode. It looks like two hosts speaking to one another. So there's something else in there doing the MPLS tunneling, like MPLS over IP, GRE, LTTP-v3. And IPsec is added on, bolted on for transport level securing of that connection. So really, just from these alone, you've got 6 different options. So which do you choose? Well, to answer that question, I also want to explore one of the other bullet points, and that's the potential spoofing problem. How bad is that, and what are we really talking about? So here's a case study of a spoofing attack with an internet back channel, and what we have here is a service provider core that has at least one PE box that is, or PE box that is enabled with MPLS, say, over GRE. We're providing a 2547 service, etc. There's an internet, and there's a hacker. So I'm going to build a packet here, build a packet that the hacker is hacked into his system to build. And in this particular packet, I have a source address of a PE or a PE. I spoof the source address of a service provider core PE. The destination address is a PE or a P router with MPLS over foo over IP. I really don't care at this point. We're just talking about this in general. So that what I have labeled is MPLS over GRE enabled PE. That's his destination of attack, and he uses the source of one of the P routers in the core. The next thing on his little packet he's building up is a GRE or LTTP-v3 or no header at all if it's MPLS over IP. So that's the foo part, right? Then you're putting on an MPLS VPN label. After that, the VPN IP packet, which is, in this case, the source address is the hacker himself, which he knows, and the destination is some host within the customer VPN. Maybe he tries a bunch of different ones, maybe he knows, maybe he just knows that it's, this customer uses 10 dot addresses or what have you. So he can build up a packet like this, and then whatever PDU he just chooses to put in here for whatever particular attack. It's his choice of PDU. He's trying to insert a packet into the customer VPN. So the hacker sends the packet MPLS over IP past layer 3 ACLs in the core. We assume he has the ability to insert packets into your core network. So if he can insert packets in your core network and hit that PE, and he can guess one MPLS label, the packet is switched into the customer VPN. So that one packet into the customer VPN, if it hits a host that requires a response, the response is actually going to go out over the internet, because the response was the hacker's public IP address. So now I've got a full two-way communication here, and I can just start picking away at the customer VPN all day long. So how hard is it to choose that MPLS label? Well, if the MPLS VPN packet can make it into your core and hit an MPLS over IP box, all that's standing between that packet getting dropped and getting switched is this 20 bits. So assuming a blind hacker can send 5,000 packets per second to a PE with 4,096 routes, I just picked these numbers. All possible valid labels can be found in 3.5 minutes, and an average of 2 are discovered per second. That's just some probability calculations. So that's fairly fast. So we're not complete and total sitting ducks here. In the isolated MPLS core case, what the various documentation says, so here in draft Behringer MPLS security and some other technical white papers, say that for security reasons, a PE router should never accept a packet with a label from a CE router. So that gets around, not exactly the case that I pointed out a moment ago, because that was IP spoofing, but this gets around the potential for an MPLS packet being spoofed from the CE. So as long as this holds true, the isolated MPLS core, the core is isolated, and therefore you cannot spoof a packet. That's kind of the conventional wisdom for an MPLS core without any MPLS over IP enabled nodes. But if you do enable an MPLS over IP, you now open yourself up to MPLS packets that can traverse via an IP encapsulation. So if you enable MPLS over IP, configure a manual tunnel anywhere on your network, you really need to pay special attention to your layer 3 ACLs at all your boundary locations. This may be difficult to maintain, subject to configuration errors, etc. And so given the ease of just a blind attacker, an attacker that has no tap onto your network, it could be dangerous to rely on the layer 3 ACLs. So a little bit more about this blind insertion attack, case study. The aim of the hacker is not to disrupt your core. In fact, he doesn't even want to be detected on your core. He just wants to use it to send a few packets and hit a PE and trick you into sending packets into the customer VPN. So we assume that the hacker has the ability to hit that VPN PE in this particular case study. So maybe your addressing is exposed, or you have one little hole in your layer 3 ACLs, or what have you. But what the hacker does not have the sophistication to do in this case is to capture and decode packets in your core for use in a real-time orchestrated attack. These are two very different things, right? The blind insertion attack is a script kiddie just blasting packets away, something that might be considered fairly possible no matter how hard you try to secure your core. Somebody's going to be able to get a packet in there, and once they can, he can just sit there and run whatever hacking tool he wants. But someone that has a tap on your network can pull out the right kind of traffic, decode it, and do sophisticated orchestrated attacks like this is seriously another level of sophistication. So we kind of try to separate those two cases. So spoofing over MPLS over IP, one correct guess on the 20-bit MPLS label and the hacker wins. So this is if the hacker can get into your core, if you've got MPLS over IP enabled, it's almost trivial for him to get a packet into the customer VPN. MPLS over GRE adds 4 bytes of header that are constant. You can look it up in an RFC and you know exactly what it is. So really it's identical to MPLS over IP, except the header size is 4 bytes larger. MPLS over LTTB v3. v3 has this interesting little cookie field. The hacker must guess this cookie field. It's 64 cryptographically random bits. It's effectively a clear text password. But attacking at 10 million packets per second, the 64-bit cookie will on average take about 15,000 years to guess one cookie correctly. So against the script kiddie blasting away, it could be a pretty strong defense. Now what that defense looks like is, say an MPLS over LTTB v3 packet gets into the service provider core, before it reaches the VPN, it'll get dropped at the far end PE. So this is, I also note, even though I'm using the word cryptographic, it's not really cryptography. That has to do with how you select the random values. It is defined that when you select the random values, if you have a series of random values, that you won't be able to predict the next one. And it's the router that's doing the random value selection. He's picking the value and sending it to all the other PEs and saying, use this value when you talk to me. So it's very lightweight. There's no additional configuration necessary versus MPLS over IP or MPLS over GRE. As long as you're advertising the tunnel capabilities of that particular PE, you can advertise right along with it. Here's a random value. You got to use it when you're talking to me. And you assume that if the person is using that random value, then he's part of your closed group of friends that are allowed to talk to you. So what about IPsec? All these MPLS over IP encapsulations may be protected by IPsec transport mode. So to IPsec, like I said before, it looks like host-to-host security. What this lets you do is keep the IPsec question separate. You do your threat analysis. If your threat analysis is against the script kiddie, maybe, and you're using v3 with a cookie, maybe you don't need IPsec. If your threat analysis includes man-in-the-middle attacks, somebody that's tapping your core, et cetera, okay, bolt on IPsec, and also worry about a lot of other attacks too. So with IPsec, the authentication model looks very similar. The packet is received. Rather than checking a 64-bit cookie, I'm going through a whole packet authentication. And it provides full cryptographic protection of each packet traversing the service provider core for the VPN service, certainly protecting against packet spoofing. It's heavyweight, requires provisioning full mesh of point-to-point IKE. Cryptographic acceleration, matching a 64-bit value is a lot easier than performing crypto across an entire packet. Synchronization of IPsec with control planes, etc. So, in summary, MPLS over IP may be leveraged for migrating to MPLS, enabling MPLS applications across multiple disparate MPLS networks, enabling MPLS applications actually over a native IP core, using MPLS only at the edge and letting you roll out MPLS at a rate that's not confined by the 2547 rollout. So IP tunnels may be configured manually with just a basic GRE tunnel, or to carry MPLS for a variety of applications, or dynamically to turn on certain MPLS applications. The manually configured tunnels actually just looks like a link, so it makes your MPLS network grow larger. However, edge applications such as 2547 VPNs may be operated over IP without manually configuring IP tunnels if you use the BGP tunnel SAFI that we talked about. So there are a variety of MPLS over IP encapsulations to choose from. MPLS directly over IP is the most efficient, but it's the easiest to spoof. MPLS over GRE has effectively the same properties as MPLS over IP, but with a 4-byte larger header. MPLS over LTTP-v3 has a slightly larger header encapsulation, 8 bytes more, but protects against the blind packet spoofing attack with very little additional operational overhead. MPLS over IPsec is the most secure encapsulation that we know of, but has the most operational encapsulation overhead that can't really be overlooked. So that's the short talk on MPLS over IP. It's kind of an update of some of the discussions and various drafts that exist in the Layer 3 VPN working group, et cetera, et cetera. This isn't really necessarily a product update for Cisco or anything. I'm just giving kind of an overview here, and happy to hear any questions.
In your attack scenario, do you assume that the attacker is sitting inside your network? The script kiddie is sending these spoofed MPLS packets from inside your network?
Which addresses? Wait a minute. I'm having a hard time hearing.
Okay, in your attack scenario in the beginning,
yes,
do you assume that the script kiddie is sitting inside the network?
I assume that the hacker has the ability to get a packet into your core network using one of your internal IP addresses, sure.
As an MPLS packet?
No, no, there's two different cases. This case that I have up on the screen now, it's an MPLS over IP packet, and it's hitting a P router that has MPLS over GRE configured on it.
So while you guys are thinking of questions, I have a question. If anybody feels like answering it, is anybody running 2547 over an IP encapsulation? We have a lot of work going on in the IETF in this area, and I'm just curious if anybody's doing it, or anybody willing to say that they're doing it. Oh, Ted? Ted is? Okay. Pardon? I'm sorry?
Can't hear you.
Mike, use the mic so we can hear you.
Which network was that?
Sprint.
Does anybody find it interesting to run MPLS over IP for 2547 support? I saw one hand, and I saw some giggles. Okay. There's a few shy hands out there.
Okay, well, thanks, Mark. And